What's up, everybody? Time to start our week of review here. I'll try to make this one quick. I wouldn't want this video to drag on for too long. Yeah, I nailed it, I know. Anyways, so check it out. Here we go. Here's our focus for today. Assignments on Google Forms. Let's do it. If I can remember how to do things. What am I doing? All right, here we go. Oh my God. Here we go. Oh my God. So our focus today, we've been learning all these different types of test intervals, right? We got all these different hypothesis tests and confidence intervals we've been working with. And the question now is, when I read a context, how do I determine which of those tests or intervals to use? And so today's practice can be, here's a bunch of contexts from past AP exams, and you're going to read them and not do them all. I mean, you could definitely do that for extra studying. That'd be fantastic. But you're going to read them and you're going to try to tell me which kind of test or intervals should you use. So as we jump into this, if you ever kind of need a bank, don't forget you got that calculator that costs a lot of money. So we go to our stat tests or our Casio. I can't remember off the top of my head. I do like that Casio a lot, though. Cheaper and user-friendly. It does everything we need. But whatever. We go to our stat tests menu, and right, these are all the options. Now, for this year, 2020 here with the distance learning situation, we've got some of these cut off. So this year, we will not be working with a chi-squared test or a chi-squared goodness of fit test. In other years, we would. That's actually, whatever, unit 8, I think, in the AP, in the College Board curriculum. We're not going to use a Lin-Reg T test. This deals with working with slope. This would have been our last chapter in a normal year. And then this F test, and then this ANOVA, right? Those are actually things that you might learn after AP stats in your next stat class. You might not even have all of those things, right? Don't worry about it. The rest of these should look familiar. Now, I will also say we did talk about with means, right? For us, means T. But there are z-tests in real life that can be applied to means. Remember, that's if we know the population standard deviation sigma. So this z-test would be a z-test for means. 2 sample z-test would be for means. But right, that's not going to happen if we knew sigma. Z interval, and then 2 sample Z interval, right? Those blue things that I just crossed out, those would all be used with means if you knew the population standard deviation sigma. That's not going to happen with one of our free response, so that's a real life thing. But for the sake of the AP exam, we just need to distinguish between what's left. So as you start to decide, a few things to consider, right? First off, and this also gets into like what a confidence interval is. First thing I'm looking for is actually what's on the bottom. So a confidence interval, right? Like if you're given a confidence level, like I hope that you realize that that's a confidence interval, right? If they tell us to use 98% confidence, hopefully that makes it, fairly obvious. Not fairly. Hopefully that makes it super obvious. But remember, the reason we use a confidence interval is to estimate the value of a parameter. Right, so if we're talking one sample, a confidence interval is used to estimate the value of some parameter. Right, the only way we could truly know the value of a parameter of a true population percent or true population mean would be if we do a census, right? Like the government's trying to do that right now in 2020. In most cases, that's unrealistic. So instead, we start with some sample data, and we use that sample to create an interval estimate, right, of the parameter. Right, so if we want to know the average age of everyone in East Hartford, I'm not going to find everyone in East Hartford and ask them their age. That takes too long. I'll get a sample, and then I will use that sample to try to estimate, hey, I think the true average age of East Hartford residents is between blank and blank with some level of confidence. Then we started to get into our 2 sample stuff, and with 2 samples, we're estimating the difference in 2 parameters, whether that's 2 means or 2 proportions. The biggest thing we want to take away here is this word estimate, right? That's what an interval is used for. An interval is used to estimate the value of a parameter or the true difference in 2 parameters. So reading the question estimates an immediate key to us that we're probably using a confidence interval, but then also this confidence level should make it, hopefully obvious. So then we got our hypothesis tests. Similar to the confidence level, if you're given an alpha level or a significance level, that should make it pretty obvious that the test question they want you to use a hypothesis test. They also use these phrases, statistical evidence, statistical justification a lot. Now, I will, on a side note, say there are many problems that ask for that statistical justification that are kind of intended to be approached with a hypothesis test that you could answer using an interval, right? And we've seen that multiple times, using an interval to decide if we think some true mean is above or below some value, or if there's a significant difference, whatever. So a hypothesis test, right? We've got those phrases, but a hypothesis test, like what's it used for? It's used to determine if a parameter is greater, less than, or different some value, right? So we're trying to decide, is P bigger, smaller, or less than? Bigger, smaller, less than. I said the same thing, right? You know what I meant. Bigger, smaller, not equal to some number, or is mu bigger, smaller, not equal to some number, right? And this, hopefully, we realize would be our alternative hypothesis. Or a hypothesis test, we might be comparing two parameters. Is 1% bigger than another, smaller than another, different, or is one mean bigger, smaller, different than some other? Right, so that's why we're using our hypothesis test. And in real life, these are tools that we use together, right, in conjunction with one another. These aren't like two separate worlds. So that's kind of the big picture of the test versus interval idea, right? How do we know which, what do we use each for, and how do we know which one to use based on some keywords? Other things you have to think about as you start to make this decision are really two main things. One, what kind of data are you working with? For the sake of the AP exam, if you're working with categorical data, if you're working with, or qualitative data, if you're working with percents, right, we're talking proportion Z stuff, 1 prop Z, 2 prop Z. If we're talking quantitative data for the sake of the AP exam, we're talking about means. It's some kind of t-interval or t-test. Now, again, as I mentioned in the beginning of the video, that side note, there are z-tests for means if we know the population standard deviation sigma, but I've never seen a free response where we have to use a z-test for means yet, right? It's more just knowing when you would do that, right? I referenced that at the beginning of the video. So we got to know what type of, for the z or t, it's what kind of data are we working with? Categorical z, quantitative t, proportions z, means t, and then we also want to know how many samples are we working with, right? So that's what we want to break down. So as we read a context, these are the things we want to be thinking about. And I would read these contexts twice. When you open your exam for your first 25-minute free response, read it. And again, that's specific to 2020, just in case we're using this some other year. But read the free response, get an idea what the question is, and then kind of go back and reread and think about some of these questions. So let's just tear through a couple, and then we'll wrap it up here. So don't want the video to, no, I won't do it again. Anyways, so here's first context. If you want, pause the video, write it down to have an example. Otherwise, pause it right now and think about what type of test or interval would you use for this. Now, I'm kind of giving away a little bit telling you that's a test or interval, but you probably got that from the title of the video. So here we've got tags placed in garbage cans. They can dispose up to 30 the garbage can hold up to 30 pounds of garbage. Got a random sample of 22 cans. Got an average of 33.2 pounds, standard deviation of 3.2 pounds. Is there strong evidence residents overload their garbage cans? So as we're thinking about this, right, you want to think, how many samples do I have? One sample. Quantitative or categorical means or proportions, we're working with means. We see that average, and then there's that strong evidence rate. So this right here, I'll put it in parentheses because this doesn't show up. The one sample part's not on your calculator, but if you like to write that, if it helps, you can. This is a one sample T test. T because of the average, test because of the strong evidence, and one sample just because like there's literally one sample. But again, on your calculator, it's just going to say T test. Side note, yes, we could use a T interval to also try to address this question. All right, but I don't know what else. I'm just going to go to the next slide. All right, next one. Pause it, read it. Think about it. Like say it out loud at your computer screen so people think you're a weirdo. What kind of test or interval we got here? All right. Driving test failure rate we're trying to estimate. Now, as soon as I see that, what am I doing? A failure rate, right? A rate is a percentage. So now we're thinking percentages. We want to estimate the failure rate. So that word's jumping out at me like, how do I estimate P, the true percent of all drivers who fail? We've got a random sample, one random sample of 65 students. And then we've got this will be our X value here, the number of those that failed their driver's test. And of course, we do 37 out of 65 to get our little P hat there. So as we think about this one sample, working with percentages, proportions, right? A rate is a percentage, 37 out of 65 is a percentage, and so it's Z. So this is one sample, proportions, And this is an interval because we're estimating that true percentage. So this is our 1 proportion Z. Number 3. What do you think? Interval. I don't even know. I'm just lonely in here. I miss you guys. Say that every time. Almost. Talking to myself. All right, sorry. Looks like we have one random sample here. Why did I put all the 1 stuff in a row? That was an accident. I just like randomly copy and pasted these, I thought. Copied and pasted. We've got the amount of financial aid. So this here is quantitative data. So this is going to connect to averages, means. We want to estimate the mean amount for 1 sample. So this is our old friend, the T interval, right? We could write 1 sample if we want. That doesn't show on our show up on our calculator, but T, because we're talking means, I just pointed to it with my finger. You can't see my hands. And then this is an estimate, so it's going to be some kind of confidence interval. I intentionally didn't put any alpha levels or confidence levels in these because I was trying to make it like that obvious. Next one. So as you read this, hopefully we notice, not that I keep clicking things I don't need, but hopefully we notice right off the bat, this is a little different because here, boom, we got 2 samples. We got dogs, we got cats. So it's already a 2 sample situation. This time we're working with proportions, right? We're working with percentages here. So we know it's some kind of Z thing, prop Z thing. We want to know if there's a significant difference in the rates of flea problems. We're not estimating the difference. We just want to know if there's a difference. And so this is going to be our pal, the 2 proportion Z test. Right? 2 samples, cats and dogs, percentages, proportions, same thing. So 2 prop Z test. Next up, got 2 merchandise methods we want to compare, see which one's more effective. Randomly assign 15 stores for type A, 15 for type B. So we got an experimental design here. Note, remember when we're checking the conditions here, we wouldn't talk about random selection. We would talk about random assignment. So we collect some data about the number of items sold at each store. So we've got some quantitative data. And we want to know, right, this is quantitative. That's not a highlighter. And we want to know, is there evidence or is there a significant difference in the mean number of items at each store? So this time we've got 2 samples. We know it's T because we're talking means. Theoretically could be Z if we do sigmas, but we don't have that. So this is our 2 sample T test, right? We're not trying to estimate the difference in numbers of items. I'm sorry, the F. We're not trying to estimate the difference in mean numbers of items sold. We're just trying to determine if there's a significant difference. So here we don't need an interval. We're going to use a test, although we could create a 2 sample T interval and see if that interval contains 0. Hopefully that makes sense. This one has no number for some reason. That makes no sense. This one, I'm going to make the whole thing a different color because this is actually a situation that we have not encountered yet. So as we think about this, as we read through, we can still use a lot of it, right? The same stuff we've been talking about. So we've got 100 volunteers. They get their time. So this is going to be quantitative data, right? An amount of time for a 1-mile run. They do that at the start of some workout plan, and then they also do it after, right, using this new workout plan, right? So we've got a before and after situation, right? Run the mile before, run the mile one again after. We want to estimate the mean difference after a 1-mile run. So still, we should have, right, T in our mind because we're talking means. So this is a really, what? I can't even speak English. Anyways, this is different than what we've seen so far. Maybe you're thinking a 2 sample T test or a 2 sample T interval, I should say, because of this estimate right here. And that's a pretty good idea. But if you recall, for a 2 sample T interval or test, or anytime we have 2 samples, the 2 groups, the 2 data sets would have to be independent. But if you think about this, we're going to have some running time, right? And this is standing for before and after, right? So we have like person 1, right? We got me, Fred Carafano, right? So this is my time before, and this is my time after, right? And then we have some other person, Liz. That's an easy name to write with a mouse, right? And so she's like, I don't know, 5.1 and then 3.9 or something, right? We would assume this makes people faster, this workout plan. But here, this time, this 5 is not independent from this 4. These two times are related because like I ran both of them. Same thing here. These two numbers, these are not independent. This 3.9 is related to 5.1 because Liz ran both of those times. So in this situation, we wouldn't want to just look at the difference in means. We wouldn't want to just compare the average for the before group to the average for the after group, right? We could do that, and that's what a 2-sample t-interval or test would do. But in this case, our better option than comparing the overall averages is like, I don't want to compare Fred's before to Liz's after. I want to pair specific values. I want this 5 paired up with this 4. So this is actually a paired t-interval, right? And it's paired because we want to specifically pair one person's after time to their before time or vice versa. Before and after is like the most common example of a paired t-test or a t-interval. So I wanted to throw this one in there because it's something we haven't seen yet. I'll sprinkle in a video, I think, maybe coming up before the exam, definitely, about how we do this. It's pretty straightforward, but we'll worry about that later. So your job, hop on Google Classroom, get up in the forums there, and like do your work or something. You're going to read each context and tell me what kind of test or interval to use. I hope you guys are having a wonderful day. I'm going to fly back to my lair, cook some food by breathing fire on it or something, and then, hopefully not get slain